All right, I was amazed by this. This one came from a single tweet. I saw a tweet in my timeline saying someone had developed a new server-side template injection payload, and it looked very complicated like SQL injection, so I was motivated to learn about this, and this is awesome. I've been talking about how bad C is, and C creates these memory corruption vulnerabilities. Well, Python 3 is also a snake pit. And so here's how it works. You can make your own Docker server, which will end up serving up a page. And modern web pages are not just a static HTML file. They're created by engines. And a lot of the engines run on Python. So you can make your own if you go through this project, or you can just use mine to exploit it at the end, which is what I'm going to do. So here's my running one that's live, running on port 6060 on one of my servers. So this is a very simple dynamic web page. So, oh no, I didn't mean for it to be a pun, but it may have well turned out. Anyway, so the point is here I can search for people. And if I search for somebody like Sam, it will always say user Sam exists. It doesn't really have a database or anything. But the point is you can put in other things here, like curly brace, 1 plus 1. Curly brace, curly brace. See, those are the template objects which are evaluated by the server. So this object is 2. And you shouldn't be able to inject those. So this is like SQL injection. You're able to inject those curly braces, and you can inject objects which are then processed by the engine. So here I can do a little bit of math in the engine. So now let's talk about what should be done here. Let me get my instructions over to the side so I can see them. All right, so the first thing is, get up to the top of my instructions. All right, the first thing is to fingerprint the server. There are a variety of engines, and here are as a truth table to figure out which of the common server-side template engines are being used. Yes, C is bad because of an awful lot of problems. The way it handles strings is very problematic. The way it allocates and frees space on the heap is problematic. The way it uses print functions is problematic. We're going to see C does an awful lot of things which let you gain control of the instruction pointer. Ultimately, if you really understand C and you write it very carefully, it's fine. It's just that it's confusing and there are common mistakes people make. Yeah. James Kettle invented this SSTI? That could be. Yeah. I never found out where this came from. But anyway, here's how we're going to diagnose it. So he says do 7*7 with dollars and one set of curly braces. So dollars, 7*7 dollars. And see what that does. And that does not evaluate the thing. 7 times 7 just sits there. So if it fails, you follow the red arrow. If it were to actually evaluate it, you go this way. So now try 2 curly braces, 7*7. So get rid of that and put in curly brace, and another curly brace. And that evaluates it. 7 times 7 is 49. So now you follow the green. Anyway, I think you'll find out that we're using Jinja 2 here. And so, that's the first thing. And now, the fundamental reason why we can now stick in data into a single string variable. And we're going to totally take over the server. And to understand why, you need to understand how Python 3 works. So let me just go to my Debian machine here and get out of this and just run Python 3. Okay, we're going to see how Python 3 is structured just from a Python 3 command shell, and it is very strange. So let's try this. If I do s equals hello, okay, that's a string. So I created an object named s. Now you can look inside that with the directory of s and see all the methods of that object. You might think a string is just a string, but a string is not a string in Python, it is an object. And objects have methods, so you can do all these things with it. You can determine its class, you can center it, you can count the number of characters, you can encode it, you can tell whether it's upper, you can turn it into upper, and so on. So notice this one here, class. every object has a class method. So let's execute that. S, the way you execute it, S dot, and then the name of the method, class underscore underscore. So it is class string. It is an object with a class of string. All right? And it can also run things like lower. And that refers to the built-in method lower. If I refer to it this way, I just get the address of that method. If I want to execute the method, I have to put in the open and close parentheses, and then it performs that function on it, and it changes the capital hello to lowercase hello. So this is where you get the fundamental issue. What you thought was just a string is in fact a very complicated object. All right, and now we can walk up the hierarchy. So we can do S class, and see that that is class string. Well, we can find out what class is S class. Class. That is class type. And then we can do class base. Yep. And that is class object. So let's look at what we've done here. I got a little diagram. We have now walked up the tree. We started with a string. We then went to the class of the string, string, and we went type, class, class, and over here we got to class object. This is the root of the entire Python 3 tree. Everything in Python 3 is an object, and it all comes from here. So starting from a string, I was able to walk up to object. I can now go down to anything I want. So let's do that. S class base is the root of it, so I can take that and I can look at its subclasses. I got to do underscores though. And there are a lot of them, many available functions. All right. Anyway, the point is, you can now hunt through all the subclasses of the object, which is everything Python has, and you can find the one called catch warnings, which the only reason why I like the catch warnings function is the catch warning functions will be one of those, and it has a method that will run import. So this mess, you can now start from a string, walk up to the object, then go to the built-in modules of this catch warnings thing, and then you can go to import. So what this means is the person who wrote this Python code that's running gave you a chance to enter a string, and by entering a carefully crafted string, you can actually import more Python libraries that the developer did not intend to import. This is mind-blowing. You can add code that isn't there, so you can import OS, and then you can execute system date. So even though they probably didn't use the OS, so at the end of this, with this very long preamble, you get code execution on the server, where you can execute bash commands from the Python. Yes, well, no, you'll see C gets about this messy, and SQL injection gets about this messy. They all get about this messy when you really do something with them. But the fundamental principle, so that's the game. So now you can actually walk up the hierarchy here and find your way to get to command execution on your server. It is kind of a mess, and it does depend on exactly what version of everything you're running, so it doesn't always have the same thing. But anyway, that's the point. Where someone was just putting in a string, you can put in a carefully crafted string that will ultimately let you do anything you want to the box. So there's some flags to find here, and that's server-side template injection, which was new to me and very fun.